Hello, we are live. And the strange thing is that the book I published about the cell towers and the reply for the cellular connection for Starlink, Amazon rejected the book because it was something fooling the, how you call it, the readers. And I think maybe because this is a speculation about what is possible with it and not real yet, because it is just two sentences in an earnings call. So I think this is the problem. So what I will do, I will keep it blocked. I hope that it is an extra minus point, but it is a little bit strange. I previously also had a problem with a book about X money, and it said that it was like some Bitcoin. Totally wrong. So I think they're using AI to check the books in if it relates from the what's in the book and what is the title. And I think there's some bug in Amazon, but I will be careful. I will wait because I don't want to lose my account again. I almost lost it because of a mistake. So strange things happen. So maybe I have to write more disclaimers in the book that it is just speculation and that is maybe science fiction or whatever. Maybe I can publish them then, but that is not what is the point. It's a technical, futuristic view of a possible product or what the technology is going. And it looks like the AI from Amazon is too realistic and it doesn't accept it. So I can always talk it about on YouTube. It's maybe the plan. So if we cannot publish it, we will still look at the book online through YouTube. The next thing is terra fab, and I think if I write a book about that, a similar thing could happen. I used to study chip design, so I know every step of how chips are made and the problems with it, the design, the etching, lithographic. I come from the Netherlands, and Philips, that is an electrics company, the mother, is the origin of ASML and NPX, so the industry that makes now the lithographic machines that is world renowned, ASML, comes from Philips. And the group of people that started this factory were there when I was in school. So it could be that some of the people that are very work there or initiators, I probably went to the same school because my school, the higher technical school in Utrecht, had the first department for designing microchips. And so we used mental graphics to design chips, and we let Philips create the chip what we designed. And at the end of the year, it didn't work because of the chip. It is more difficult in that time to make a chip. It is not just like a PCB, an electric circuit. It is so small that it interacts with magnetic fields and heat dissipation. So you can make a good design on paper, but in reality, it doesn't work because some magnetic or some other problems. So this was also software that could test for it. And of course, we did the first design. We tested. We make a very simple, in 1 year with the whole group of the class. We make the design of a chip, very simple chip that is known. So we knew what the answer was, but we just copied it. But of course, the wiring and how it was built was a little bit different. But we thought, okay, we made our own chip, has to work. And we made Philips made a small production of that chip, and it didn't work at all. So then the next year, the class had a demo chip that didn't work, and they want to research why it didn't work, what is the failure. And so it was research. So first year was designing the chip, second year was to debug the chip, and then I think the project stopped because the idea was that Philips financed the school to build a chip factory between the German and the Dutch border, and it was never built. So that's why all the people that studied went to Korea. They did cell phone chips design, and they spread all over the world. And for chip design, and most of them didn't go in chip design because it was not too much factories or places where you can use that knowledge. Most of them went into the normal electric designs, and some people became programmers like me. So about terafab. So I have to have an idea what the terafab is because that was my specialty on school. I studied electronics and computers and chip design, telecommunications and high power electronics. So I must know a lot about what Elon Musk is planning and doing with this biggest factory in the world. what he is saying in the first time when I hear it, I said, it's not possible. Now I hear that next year he already will have some chips that he can make. This is not the terafab. This is the research lab. So he's building in the same building, I think, a research lab and the terafactor. Or maybe it is separate, but he will start making chips, small amounts of chips in a research center to find out how to make chips. And this is the same what I made with the chips we made with the class. You can have the theory, how to make a chip. You can use a computer to test it. If you make the chip, it sometimes doesn't work. We had for mental graphics, we had an electromagnetic field simulator. We had heat. We had all kind of magnetic field. We had electric field, and we have heat testing for the chip. I can imagine if you have high frequency signals going past each other very close to each other, they can cancel each other out, the magnetic field, so your currency disappears. And if the chip is small, there are all kinds of magnetic fields generated by the chips. It is high frequency. It's like a radio. It is almost an antenna what you build on the chip. It is all small, so there's a lot of problems. The purity of your design, if your lane misses a little bit of material, there can be a hole. So the wire between two components is broken and it doesn't work, or it does work but behaves different. So these are all problems he has to learn, and this is what the value is of TSMC. It is not how to use. It is how to use the LSML machines, how to optimize them for every design. So if you have a chip, they have to calibrate the machine. If another chip, they have to recalibrate the machine, and they have to have at least an 80% or higher than 75%. 10% or 15% fallout. You can imagine you make a wafer, they will not be all good, the chips. There is maybe half, Mukashi, there was half of it, of only a third usable, 60% you throw away, and that is not expensive because it is just silicon, so it's just sand. But with these chips, it becomes bigger, and the bigger is the chip on the wafer, the more fallout there is, because the error of the chip is the surface of the chip. So if you want to make one perfect wafer that is where no problems this is almost impossible. I think you have to make 1 million of those wafers, and then you have one wafer that is perfect. So what they do is they make more smaller chips, and half of it they throw away, and then still the half they have left can have problems. They have to test everything, and again, an amount of chips are thrown away. And then you have some that you can still sell that have some errors but less memory, so still you can sell it. And the rest is perfect, and you can ask a premium price for it. So sometimes you have these GPU, or you have these video card things with different memories. So one is perfect, that is with the high memory, and sometimes you have like the half of 1/3 of the memory that are chips with errors. So still the error chips with some defects can still be sold, and they sell it for a lesser price, and mainly it is in the memory piece. So that is a little bit of talk about quality. So you can have the perfect design, you can steal the design, you can steal the settings, but you have to have the setting for the specific design. Then you can run it, and then how you treat it, the gas, all the other settings, that there are millions of settings how to make a chip. You have to know exactly, and then then you can copy TSMC. It can be that Elon Musk has his own way of thinking and maybe simplifies it, and it is easier to dial in these settings. And I think that is why this research lab is built for chips. I think he knows. First, if you walk you listen what it is to the machine is like one of the ninth wonder on Earth. If you understand how an ASML lithographic machine works, it is like a thing out of the future. It is an alien technology. So how this laser makes this, and how the inference. So you have a design, and it has to be converted in an inference pattern of the design, and that is projected on the wafer. And because of it is so small design, it has an inference pattern of your design, but because you have an inference design of your design, you get the correct design projected on the chip, on the wafer. So that is totally crazy. It has to do with quantum mechanics. It is highly, highly technology. That's why almost nobody can copy them. Then so even if you have the design and you make the chip and you have light it up and you have to lithograph it, then still the process how to treat it, how to make it. And there are multiple layers of. There's not one layer. There are multiple layers that have to be done. So this is a very difficult process, and I think to get it the first time right is not possible because China and other countries all tried this technology and most of them failed. They don't fail at a lab or one or maybe 1,000 or 1,000,000 chips. If you really go mass production, so TSMCs, and they have to pump out millions of chips, and those chips has to be, every wafer has to be like 80% okay or higher. That is the problem. And that is the question, can he do that? I think he can make chips. I think next year he'll have chips, not as much as he thought. I think there will be a lot of, maybe 50% of more will fail. Maybe only 30% of the chips in the wafer is usable and 60% he can throw away. But this is, I think also with AI now and maybe with new technology, he will have to pump it up to 85% that of the chips made on the wafer are all okay. Then he has to go for how can I make it 100 times more or maybe 1,000 times more. And I think he can do it. And if you make parallel streets, then it becomes also the problem, the building itself. It cannot be shaking. It has to be, you can imagine if you have a small, that's 1.4 nanometer design. If there is a truck driving a kilometer away from the factory, the shaking of that truck influences this laser. So this is crazy. So sometimes these buildings are built in water and the buildings are floating and then they are isolated from the environment, from the shaking of the ground. Now these days, I think that was the old day. That was the old design of the buildings. I think now these buildings, the technology is better and maybe the machine itself is in a specific or the lithographic piece of it is in a Sugoi stabilized environment that if a truck drives by, it still is okay. Now you can imagine if you want to have a space where it is where you have everything in control, the movement, etc., is space, out of space, or is of course much better. So I see also that these factories can build in space or maybe on the moon. So you have to have, and there's also in space it is there is no oxygen, so you have a vacuum, and you don't want to have dust particles on your wafers, so it has to be a clean room. Now the whole building is clean. I think Elon Musk was thinking just the wafer and when it goes into the machine. If you make that a clean room, it's much smaller, easier to build. That's much better. So I will see that what he is thinking to make is possible. It is faster to build and at a bigger level, because if you take the clean room, not a clean room, but the machine and the product is moved in a vacuum or in a clean environment, is easier. So he will update the factory or the process of how to make chips. I think the design he can copy, the machines he can copy, and I think it is just first learning, but because he works with Intel, learn how Intel would do it. And he optimized it. He tried to avoid this clean room. That's the first thing he will try. He will use the machines, maybe change it a little bit so that he can use cartridge with wafers that go in clean and go out clean and move to another machine and goes in clean. So this is, I think he can do that. So, but he said you can smoke a cigarette in the factory without any damage to the product. So that is an advantage. There's always a cost of production. Then he has to go for this. So he has FSD. Everybody knows it's just a race of nines. It has to be a perfect. May not make mistakes as a self-driving system. This you can compare what he has to do with chips. He has to make this one auto wafer. I think if he starts, maybe this 10 or 20% of the chips are okay. He has to scale it up at least to 50%. Then he can start making them a little bit more. And if he really wants to be profitable and everything be okay, he has to think about 80%. He can also think, okay, I throw away 50%, but I make like a crazy amount of them. That could be, and then he finds later out how to increase this 50%. So he just makes first the factories, the dialing in can be something for later. This can be a very interesting approach to it, and it probably works. Because if you have unlimited money and you just will need to build this straight, and you know that this is the design, and only I call it the tweaking of the machines is the problem. Just build not one but 10 straights at the same time, and you have then also 10 times more chance to find how to set it up, because you have 10 machines at the same time to experiment, and then you find much faster how to set up this machine or the settings. So I think it works. The thing that I amazed of that is he can already start with a research lab and production. Maybe this is just a copy of an existing setup, but a little bit changed. And I think then 2 years later or a year later, he will start to get something out of this terra fab. And this is, I saw the plan, it is enormous. And of course, he will build first a piece of it, maybe a tenth of it. There, put a line of a factory for chips or memory and start to build it already out. And then he will, while he's building the whole facility, he will add more production to it. So he will already, maybe memory is the easiest way. So he makes memory, not AI chips, maybe memory is easier. So he will also start already with one line of memory. If it turns out to be okay, he can produce that. Then if they are building out the factory, he will build out the lines for memory, and already has the advantage that it is cheaper. So you can imagine, I thought in the old days, a chip, and RISC chip was only $1 to make. That was the 14 nanometer, this is much bigger, but I still think if you really think an NVIDIA chip, even with some profit, normal product, I think will cost only $500 to make. And I think the real cost is maybe $50. But if it goes, the material, if you only look at the material, I think it is around $50. You need some chemicals, you need some lighting, some machines of payment, payment of all the machines and whatever contracts, make it $500. But they are sold for $50,000, these chips. So you can imagine it is at least 100 times over the times the price. If you can make your chips yourself and memory yourself, you can buy them in 100 times cheaper. So that's also what the problem was for his robots, was that the chip would be, if he wants to sell the robot for $20,000 or $30,000, he cannot do that because the chip that is in it is already $30,000. Yeah? So he has to reduce the price to $5,000. That means he only takes probably a 10 times profit if it is $5,000, and then he can sell it, or he will make it even less. But with NVIDIA and the memory that's now there, they will never accept a 10 times profit over the product they make. They are in the 70 or 100 times. So that is why he's making this terra fab. About solar, I think that will be another factory, or he will do it in the same factory, because solar is also silicon, much easier. So maybe build a solar line or two and use that space. The machines for TSML and the machines he needs for, I think, for chips and memory, he has to wait. Those are only a few made per year. TSMC, the ASML makes, I think, 80 machines a year or in 3 years. And you have to wait a year or two. So maybe he has to wait for his AI chip machines to be delivered a year or 2 years now. And his space of his factory is building out like crazy. So why don't you use that space to make solar panels? Solar panels are much easier. You just take the wafers, do some simple chemistry process over it, some lighting that is you can buy a mass and just pump out millions of solar panels, and he can use them for in space. He can use them to build data centers in the desert. He needs 5 times more solar panels on Earth than in space, so he can flood the market with cheap solar panels, use them for housing, use them for electric cars, use them for semi-truck power stations, and use them for, in the desert, this mind pot of, what is it? These racks that you can place manageable, like a satellite, without, not in space but on Earth. But the solar panel has to be 5 times bigger, and only can work during the daylight. But that is not a problem, because if you have reference or you have like projects, you can stop. These days you can stop a process and restart it the next day. So during the light, 8 hours or 10 hours a day, you can have an enormous amount of power in the desert. You can run maybe in 10 hours a model, to create a model. And then if it switches off, it switches off. And if you don't make a model, you can use it for inference. Maybe you can say that during the daytime, AI is cheaper power, and some factories or people that work in offices, they can use it. And for other research, it will be limited to the daytime. But even then, it will be usable, these things in the desert. And maybe he can pack them up and move them like containers. Maybe later put them in space, or move them to another place, for example, where there's more energy or batteries or whatever. So it's not wasted. So he will need a factory to make an enormous amount of solar panels, more than chips. Maybe it is in the same factory or a different factory. So is it doable? Is it a dream? Yeah, of course. Every analyst looked at it. This is nonsense. TSMC takes 10 years to make a factory. Samsung also years and years and years. And he thinks that he can make something in a half a year. First mistake is it is a laboratory, a research laboratory, and that will produce chips next year already. So these are not for mass production. This is just concept and for research, how to make chips and how to improve it. The next year, I think he already has built out his factory and for a bit, and has space for a line. And I think that will be the first prototype line. Maybe memory, if it is easier to design and easier. So what is so easier to make, but it doesn't matter if he makes memory or the chips. He will save a factor of 10 of cost, or maybe more. So the investment will pay itself off if he can make his own memory, only half of it. It will already it will generate so much money with this cheaper way of production that it will earn back the investment of the line. So second line will be easier to buy, and then if he has 2 lines, a third or fourth line will pay for itself. So I think the trick is if he starts to build out, and he said, say 20% of the size of the usability, so only 20% is used. This generates so much money that he can build out the rest of the factory with the money that is created as profit from this 20% build out. So, and if he uses AI around the time, he will go exponential. So this growth from 20% to 100% goes much faster, from 1% to 0% to 20%. So when he builds it and he has a product that he can use, and it runs, and it has a 20% size, I think the last 80% will go like much faster than the first 20%. So what does it mean? If he can do that, he has the processors for in space and the memory into space. He can build databases, but also AI reference, AI compute for new models. He already has so much space on Earth, and with his Colossus and microheart, that he only needs 10% of the capacity of his data centers to make a new model. So that's why those models are going out like crazy, and the rest he can already rent for inference. The biggest business will be inference, not making models. The compute power, you need a big computer to do it, but you only need it. It will run very fast, what I understand. Or the usage is not 100% of your whole capacity of your your AI data center. Of course, I think if he makes a new model, he used the full capacity, but maybe it runs in a weekend. In a few days, he has this model already, and then he has to check it, and it takes maybe 2 weeks. And then he has no use for it for 2 weeks, and he can rent it out. Or if he has multiple of these factories, he can only use one big colossal to do the models, and the other two that are a little bit less, but he cannot handle his model. He rent out to other for inference. I think that is the big business, how he makes money, and what will be the money maker in the future. And if he builds in space stuff, there you can run a model for a long time in the sun, and maybe F reference is a little bit slow, but for human to machine, it is fast enough. And also for building long, like you want to have a research scripture or some physics problem solving, you can run it remotely for days, and you can put it in space. You don't have to have it on Earth. You don't have to interact with it. So only the fast interactive things, you need something on Earth, or you need some local AI in the machine itself or in the robot itself that handles the quick reaction. But for the long thought, it will be in space. So I think also the robots and maybe a piece of the cars will be, the intelligence will be in space. The reaction will be local with a local AI chip with reference. So the robot can react and pulls his hands back, and the control of the body and also the control of the car will be done locally. Also the reactions that it can move in traffic. But if it needs to plan or it learns something and it wants to update itself, this will not be done locally, this will be done in space. And I think also for robots, you can imagine a robot can walk, but if he walks from point A to point B and he has to think what he's going to do at place B, this processing of what to do and what to learn a new skill, he does that in space with a big machine. Then he gets the instruction, maybe his model is updated while he's going to place B. Is he at place B? He knows how to, for example, how to do gardening. So he does gardening, he collects information on what he is doing with gardening, uploads to the cloud. So everybody can learn of his experience of gardening. He walks back to home, then downloads all the new information, how to do the washes or how to do cooking. When he's at the door, he gets a new update for how to do the wash and how to do cooking, and he starts doing wash and cooking. The next day, he walks back to the garden and he gets what he experienced the previous day, and the millions of robots that did gardening, that new experience he also gets. So all this stuff will be done in space, and that's why intelligence will grow endlessly with the experience of robots that updates this model. So that is the unending term of intelligence and experience, human experience or robot experience, that will always need more and more space. So he can build out this endlessly, and robots will be more like humans and will surpass humans. And if it surpasses humans, it needs even more data, more power. And it doesn't need it on Earth. It can be in space. And space, what is there? The factor, the limited factor is spaceship. And at the end, it will be the moon. And at the end, it will be the resources. So they will go to astral belt. And at the end, it will grow all over the solar system. But we are on a good way. If you can show the world that you can so easily build a terra factory, he will build another one also. I think he will first keep it in America, then in Europe, and he will be very carefully in Asia because of China. So I think, Elon Musk, listen, if you build one in Asia, build it in Japan. First, Japan is getting older and older, less people. The terra factor only uses 3,000 people, so there are 3,000 people in Japan that can do this work. Or you can hire them externally, and it will be not a big pressure on the country itself, or in the place where they come 3,000 people. Maybe half of them can be robots. So this is okay. And you build it next, maybe not in the same place. Right now the GSIN was where the SMCI thing is. be informed by Japanese where is the best place to build this thing, where you have the space and where there are almost no typhoons, where there are no hurricanes, and where there are no tsunamis, and where there are no how you call it, Jishin earthquakes. To find the correct place will be expensive, maybe buy the whole town or the whole area, build this big factory in Japan for Asia. I think Australia can also be nice. Yeah, maybe Australia in the desert, build there something. That you have the problem of the engineers. You want to have to do something Asia, so maybe it is close to Taiwan. If something happened to Taiwan, you can imagine the people will run away. Where would they go? I think probably to Japan. So, and also now with TSMC in Japan, Taiwanese will go to Japan, and there's a good relationship between them. So don't build it in Taiwan. Don't build it in China. Don't build it in Philippines or small Asia, Vietnam. You can build it in. Don't do it in New Zealand. So Australia and Japan are your only two options. And make your decision. Maybe Australia is too English. Did you want to go to Japan? I would go to Japan and also build a Starship launching place. So not only the factory, the Terra factory and the car factory, but also build out something with SpaceX for really Starship. Maybe buy an island and put it all in there. I think there are possibilities now and maybe in the near future for Elon Musk to do something in Japan. I hope he will do that. I think he will amaze analysts. I think in the next earning call they will see that what SpaceX was saying, and they thought, it's just like a hype. They will tell something and they will never accomplish it. With Shockwell, I think they will show with the next earning call, number 3, that they are on the right track. And at the end of the year, people will scratch their head from, what is this for a company? And I think around the end of the year, he also has full use in the factories and in the design departments and from his AI. And in 2027, he will have help of robots. So maybe the Terra factory will be, when they're halfway building, they will have Optimus help building the factory, or maybe applying on the roof all the solar panels. It will be done by robots and not by humans. Maybe we will see that. That will be an enormous advertisement for Optimus. So that will also grow crazy. So I think if he can, end of the year, that we are in 5 months, 6 months, if he can prove Starship can go back in one piece, both pieces, and the reusability is possible, and he goes from a cadence from once a month to once a week, and he blows up and puts out the Starlink 3, and people are going to see that it is working with phones, and the rollout for the cellular module is a reality. I think this stock will, the company will go up, and people will not doubt it is now. There has to be an announcement before the end of the year if there is a merger with Tesla. It has to be done before the end of the year. If not, or whatever, 2027 will be a crazy year for Tesla. If it is separate, we will see the Semi taking over, Robotaxi going out there, Optimus getting ready. We will see with SpaceX, we will see the Starship getting in full production, Starlink creating a crazy amount of money, and XAI even 10 times or 100 times more as Starlink. So they have an enormous product that is the Robotaxi, still the cars in FSD. For Tesla, I mean, and I think the silent thing will be maybe solar panels, the Terra Fab, and what is it, the Semi robots. So that is a thing that will be the end of 2027. We will see the robots, so that will push up the stock. It will push up everybody's mind. SpaceX will go crazy. They will see the end of the year next year that they can go to the moon. They have everything to the moon, and maybe are already landed on the moon with a robot mission. So this next year will be amazing, and we have to see if these indicators that it will become a fantastic year this year Also, we have the midterm elections, politics. What does Elon Musk do with politics? Will he enter the arena again and screw everything up, or this time it will be okay? Will the merger be accepted under this government? I think the problem will be next government will be more difficult. If it is 2007 and 2028 will be an election year, how will that influence all the things he best built? It can be that he is stopped with everything, that he has to move country or whatever, or he stopped. We don't know. So the big chance for the development of his industries is 2027. There, all the pieces fall together. The problem will it survive 2028, especially with the politics in America? If it survives, he has then maybe 4 years or 3 years to run up, and then it is unstoppable. He will have the moon, he will have Mars, he will have all the data centers, all the data power in space. So he will be the leader in AI, he will be the leader in robots, and he will be the leader in space. And probably that means leader in telecommunications, energy, and maybe UBI will be then introduced because people don't have to work. And maybe then we see already how robots will take all over the work, and AI, the office works, the virtual work will be all. We will experience that, the beginnings of that in 2027. So I talked now 36 minutes. I think this is it. You can see I will maybe dive in deeper if there are more information about when I start writing the book over the terafab. Probably I will not publish it, or a little bit, because I think I will get the same problem what I had with Starlink, with Amazon. So I have to find out how to unblock it or whatever. Well, I keep it blocked. Terafab will be a really interesting thing. It is really, how you call it, a change. If he can make it, then this whole memory and chip thing that is so difficult and it's so protected will be broken. China will be frustrated because if he can do it and they still cannot do it, they will be making the chips factories. He shows how easy it is. In 1-2 years, he has a production line. They still tried it once, 8 years, didn't work out. They could not get the quality as TSMC, and they gave up. Now they have machines like ASML, or they hope that takes at least 3 years to develop. Around that time, terafab is already finished. So they will realize from this guy is a totally different level, alien technology, alien speed. And that is how you have to see Elon Musk. A lot of people that are fans overestimated him. Oh, it is easy. It is not easy. If he cannot dial in it correctly, if he doesn't get the machines, if there's a politic change, all of this is a fantasy. He has the help of AI. He can be flexible, he can pivot, so he can avoid a lot of things and he can correct a lot of things. He can correct his path. So first he thought Starship had to be made from carbon fiber. He realized later that it was steel. He changed the motors, he changed everything. So he is changing while he's developing, getting to his goal. This will also help with Terra Factory and all other things he's doing. So if you think you understand Elon Musk doesn't understand himself, and he can also not foresee the future. So he's continuously adapting to what's happening. He wakes up every day with being afraid for AI because he doesn't know what happened the previous day. Every day is a new experience, like something Zen. Every day is a new experience. Every day he has to adjust. He has to sometimes correct his path for the future. He has to throw away ideas he had or whatever. So if you think you can predict Elon Musk or what he's doing, he cannot predict himself. That's why he overall underestimates his own future. So for us, for me, that's understanding Elon Musk is, if Elon Musk doesn't understand himself and what is going to happen, there is no use for understanding him. So this channel name is a little bit strange, but it attracts people, I hope. I don't understand Elon Musk because Elon Musk doesn't understand himself. And that is the understanding I have of Elon Musk. He adjusts, he pivots, and that is his strength. He doesn't have like in Japan, if you go a direct way, you never change the way until the manager dies. Huh? Sometimes you have in the corporate world in Japan and vision of like at Toyota, we go this in this way and we don't change. For example, electric cars for Toyota, they tried it, they went to another way. Then somebody else came back and said, "No, we go EV." And then he was crawled back by management or by other powers and was pushed again to hybrid and not EV again. So sometimes you see these powers that if you have a management or a culture in a group, it doesn't change the company. With Elon Musk, this is totally opposite. It's so flexible. It can maybe only done because they are Americans and they are flexible. And he rotates, I think, his technical engineers. And they are not only specified for cars, for the engine of the car, they know the complete car. And there's also the bright-minded engineers that can use solutions they found in the car industry and apply them in the space industry and apply what they learned there again in how to build an AI computer or a data center. And if you have an engineer, sometimes you work at a specific piece of engineering where something is found out or is common, and this can be put use in some other engineering, and they don't know it. That this solution of this way is possible, and if you can bring that from the other engineering to this other sector, it can jump it forward. And I think this is the big advantages you see with what happened with SpaceX helping out Twitter, how SpaceX helps Tesla and Tesla helps SpaceX in construction, making factories. All is a synergy between the different engineers that are specialized on different pieces of the field of engineering. And because if they are a community and they work together, they can solve problems with different minds of different thinking to solve a problem from different angles. And this is the power of the team behind Elon Musk. Elon Musk has a specific vision, but he learned that he can adjust the vision. His end goal is Mars. It doesn't matter if he uses a Starship or the Enterprise he has to build, or he has to build a Millennium Falcon to come there. His goal is Mars. And I think that is the strength of Elon Musk. It doesn't matter how. If an engineer says this is not possible, but this is possible, he will go that way. He look at all the possibilities, find the best path, try that. If it doesn't work, he goes another path, because there are always multiple solutions for a problem. You just have to find the right solution. So if you follow a path in one direction and it goes to a dead end, you stop. You take another branch, you go back, take another branch. So what he did with carbon fiber, he started to develop the tanks. They exploded, a problem with heat and contraction. And then he said, okay, why don't we try steel? He tried steel. He could make a new kind of steel that was much better in the behavior than he thought. And he thought, wow, structurally it is strong enough. Why don't we build everything in steel, and it is 10 times cheaper and it's easier to manipulate and to correct. If something is bent, we can bend it back. If it is carbon fiber, it breaks and you have to build the whole thing again. So these things he learned. Also sometimes with an interview, something from why don't you do the trust is not the same way if you do there. Yeah, I didn't think of that. And he adjusts with the talk with the journalist, or just somebody gives him an idea. He implements it, and it is a cost saving. He has not a pride that his idea has to always work. He accumulates ideas, find the best one, what is easier to realize. And he always has to try to remove all the, so make it as simple as possible. Overhead is not needed. So why? Because it's easier to implement and to test if this is the solution. If not, go another way and try that. That's what I also did with myself with programming and projects. You go a specific path, use specific software, then you see this will not work. You go back, buy other software, test it again. Yeah, this works. Okay, then you follow that path, because it's like a tree. Your goal is here, and you have here, and you use it becomes like a tree like this, but only one of those branches will reach the top. You don't know of the 20 or 50 things you can go to the top, which one it is, like a maze. So don't be disappointed if it is a dead end. You know that there is another end. This is also with AI, locally maximums. Sometimes an A grows intelligent and it stops and it goes in totally panic mode and it doesn't work. You have to go back. That this was not the maximum. That was a sub-maximum. You have to find another maximum that is nearby. So you have to train a little bit different. It finds another maximum, goes higher. Sometimes that's also the thing, the race of nines. The super maximum that goes to the top, that's 100%, maybe doesn't exist. But what you can do is you can find a better maximum. So the races find every time a better maximum. And that is an endless job because it's like you want to go closer, 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 but will never touch each other. Not always a space between it. And this is also with this thing. You optimize to 100% is not possible, but to 9.9999 is possible, and 9999999 is also possible. And the last 999, that is what the goal is. So the terafab, he will make mistakes, he will adjust, you will see that he will make mistakes. The first production line will be in 2 years, or he will laugh about it. And then even he knows that he was building the new one, he will know in 1 year he will laugh about that. Also, a nice story was he was building the car line outside in the tents, and he found out that it was difficult. He had the motor to push the car through the tents, and then he made it in a slope. Now it slided easily downwards, and he didn't need so much power to push the building, the chassis of the car. It went down slope, and it was easier to do it. And you can even maybe with hand push it, and then you adjust it, you add more, and you push it. So when he built the factory, he made it in a slope, so the cars slide down the slope when they are created. That is only something you can learn when you do it, and when you adjust. Okay, this is a solution. Maybe somebody found it. I will use it because it will save money. It will save motors, whatever. If the motor from the line stops, you have a problem. And now you can even with hand pull it down because it is a slope. It is less faults, more uptime, less problems. It is just you have to build your building in a slope. That is the only thing. But the problem is you have to do it from the beginning. A lot of things is how do you initiate a project, and you make it in a way that you later can still correct everything you built before. So you have to be very flexible in your design. So probably this terafab is just a big hole, and what's inside will be adjustable for what is needed, and how he will correct the line, the production line. I think it will change maybe until after 3 years or 4 years when it is built out. I think it maybe will change 5 times or 6 times. The total concept of the line will change during, I think within a year, maybe 2 times. This is my talk. We are almost 50 minutes. I hope people will listen to news about the Terra factory a little bit different. It's all experimental. You have to wait and you have to see the milestones. Those will be announced by analysts, and don't listen to the hype. Don't listen to the negative news. Use AI to check what the news is and what is realized and what is possible. These days we have like 5 or 6 different AIs. The AIs go on the internet, they gather all the information, give you an overview of what is, for example, what is done already for the terafab. The ground is built, there is water there, and there's gas. Use AI to get your information. Don't always listen to analysts. That's it.